Hello everyone and welcome back to my channel. Last month we took a look at an overview of how lenses work, and today in the next installment of my How Cameras Work series we are going to take a look specifically at how aperture works. I'll show you how that physically operates in the lens and how it affects your photo. So what is aperture? Well, the aperture of a lens is the opening in the lens that the light passes through, and typically it is adjustable, so you can have a wider or a narrower aperture. We make it adjustable by putting little typically metal blades around the outside of the lens, which are actually straight pieces of metal, and they can be moved in and out in order to make a larger and smaller hole. We use a series of these relatively straight blades since we don't have a particularly good way, or any way actually, of making a solid piece around the lens that can actually expand and contract. It has to be in multiple pieces. And since the edges of the blades are not going to exactly line up to a circle, as you have more blades, you get a rounder aperture. So lenses may have 5 or 6 blades, and those are going to tend to have fairly straight edges along them. And then as you add more and more blades onto the lens, you get a rounder circle. A rounder opening gives you a little bit smoother of a background, makes those bokeh balls look rounder instead of being more like hexagon shaped or something. And so people generally favor more blades for the aperture. Most people right now are liking about 9 blades, but you will still see cheaper lenses and older lenses that have fewer than that. But 9 blades right now is kind of the standard. So why does the aperture in the lens make a difference? Well, obviously a larger opening is going to let more light in, and a smaller opening is going to let less light in. So that's simple enough, but it also makes a difference in the depth of field. Now, as I explained last time, an option for focusing in the camera rather than using lenses is to use a pinhole camera, which lets light through a tiny hole. And when you do that, the light from a single point on the subject is only able to reach a single point on the sensor. And you can go back and watch that video, of course, for more details there. But this actually applies with the aperture in the lens as well. So we can focus our lens onto a focal point on the subject. However, if we have a wide aperture, then the areas in front of and behind that focal point are not going to be in focus, because you've got light bouncing off of them and hitting at lots of different angles on the sensor, which makes everything blurry. If you tighten down the aperture, the light can't hit the sensor from as many different angles from those areas that aren't being focused by the lens, and therefore it makes those areas look sharper. So tighter aperture gives you a broader depth of field, and a wider aperture gives you a narrower depth of field. If you're trying to get a nice blurry background, you want a wide aperture. If you're trying for lots of things sharp in the photo, you want a tight one. Now, aperture is somewhat confusingly described by an f number or an f-stop. And there's standard values for these, but they don't seem terribly meaningful at first glance. You've got 1.4, 2, 2.8, 4, 5.6, 8, etc. And somewhat more confusingly, the lower numbers actually refer to a larger opening with more light coming in, and the higher numbers refer to a smaller opening with less light. Now, each step up to a larger number cuts the amount of light going to the sensor in half, and each step down, conversely, doubles that amount of light. Confusingly though, cameras also don't necessarily let you adjust the aperture in full steps. So Nikon, for example, uses a third of a step per click of the little aperture wheel or whatever. And so thus 3 stops up is going to make your light to the sensor be cut in half, and the other way around, 3 down is going to double the light to it. So each time that you change the aperture value on your Nikon camera, the light is being adjusted by a sixth. And of course you can look up the amounts that your particular camera is adjusting that. And camera manufacturers do that so that you don't have to change the aperture by a large amount. You can use smaller amounts, and practically that's not going to really cause any issues for you. So what is this magic number, right? So the aperture is the reciprocal of the relative aperture, which is the diameter of the lens opening divided by the focal length of the lens. Practically, what this means is that as a lens is getting longer, you need a larger opening in the lens for the same aperture value. And so with a long lens, less light's getting through, you need a bigger opening to get the same amount of light toward the sensor. So if you ever have wondered, say, why can't I just go out and buy myself a 300mm f1.8 lens? Well, the aperture for that I think would need to be about 6.5 inches or 17 centimeters, which just is not going to be terribly practical, right? Nobody's really going to want that. At the shorter end, though, a 35mm lens can achieve the same thing at just like 3/4 of an inch or 2 centimeters. So faster lenses tend to be in those shorter focal lengths just for practicality and expense. Of course, your depth of field does decrease as you go to a longer focal length. So if you're zoomed out to 300mm, you're probably not going to feel a need from the depth of field standpoint to go to a 1.8 lens, but you are obviously losing some light that way. Camera manufacturers, though, I think are just betting that most people aren't going to want the extra expense and extra size of a very large lens. Realistically speaking, though, you're not going to need to do any of this math when you're out in the field. So if you're like me and you're just always curious to know how things work, now you can have some peace of mind understanding what the aperture number means and why different lenses are available in different apertures and at different prices. But when you're actually out taking photographs, for the most part, you can feel free to disregard that information. So how does this actually affect your photography, though? What do you need to know about the aperture? Well, you need to know, of course, that a wider aperture is giving you more light and that it is paired to a lower f number on the camera. So if I go down to, say, f1.8, I'm going to get much more light into the sensor than if I went up to, say, f22. And so you might adjust your aperture to match a specific shutter speed that you want to be shooting at. So if I wanted to, say, blur some water, I might turn my aperture way up to, say, that f22 range in order to use a much longer shutter speed to give me that nice motion blur effect. On the other hand, if I'm out at night and I'm trying to capture a picture of a friend who's maybe moving around, I'm gonna want to turn the aperture all the way down, get a nice wide opening, letting in lots of light so that I don't have to use a long shutter speed. At the same time, though, the aperture is affecting your depth of field. So if your goal is tighter aperture for a slower shutter speed, you also have to keep in mind that this is also going to give you a much wider depth of field. The background behind your subject isn't going to look as blurry. The foreground in front isn't going to look as blurry. And so you can adjust the aperture as well depending on what kind of a background or foreground you're trying to achieve in your photograph. And you have to keep in mind the way that those things are going to affect each other. So as you change the aperture in order to achieve a particular depth of field, You're also changing the amount of light that you're getting. Now you have to change your shutter speed. Your shutter speed is going to change how blurred things might be in your photograph, and so forth. So all of these little pieces are kind of connected to each other, and you as the photographer either have to or get to, depending on how you want to look at it, figure out how to balance them all out to create whatever work of art you're trying to create. Now, if you're using the auto mode in your camera, it's going to pick the aperture for you as it tries to properly expose the image. And so this is a reason why you may want to learn how to use the aperture priority mode, usually depicted with a little A on there, or the manual mode, so that you can define the aperture for yourself. On a mirrorless camera, like the one that I have, you can actually see live feedback on the screen or in the viewfinder of the effect that your aperture is going to have when you're in that manual mode, so you can see how bright or dark the image is going to be, as well as the effect that that has on the background, which is extremely nice. That's a great advantage of mirrorless cameras as opposed to a DSLR, where you're going to want probably to take a picture at that aperture and then play it back on the screen, have a look at it, and make sure that everything looks the way that you thought it would. So that is all for today. Hopefully this helped you guys to understand the aperture in your camera a little bit better, and physically how it works, as well as how it plays into the way that your photos will look when you get them done. If this was helpful to you, don't forget to hit that like button on the way out and to subscribe to the channel so you don't miss more videos in this series explaining other things about lenses, videos out doing some landscape photography in the field, and so forth. As always guys, thank you so much for watching, and I will see you in the next one.